Thank you very much. Can you all hear me? Yeah. So the title of my talk is, as you see, Tools and Practices Enabling Growth at Klarna Bank. So it's not exactly about data catalog. I think there was some changes in speakers. So I'm going to talk about this and nothing else. But it's a broad subject, so let's get started. And first, a few words about Klarna and Klarna's projects. Who has used Klarna? Yeah, it's a bunch. But for those who haven't, perhaps I should make sure we're on the same page. So Klarna does have a checkout. It's integrated with a number of online merchants. This is what it looks like. And the idea is that the checkout should give minimal friction in the interaction between the user and the merchant and Klarna. We extend soft credit, pay later, you can see it's called there. And we also have a mobile variant of the checkout. Now, what's the value of providing a checkout to merchants, you can ask yourself. Well, it's all in the details. So this is just a carbon copy of the sales material. It's the advantages for retailers and the value for the consumers. And I want to highlight a couple of those in order to point out what kind of technical problems we have and why this is interesting. So for consumers, we have minimal input required in the checkout. We have one-click purchases for returning customers so that they wouldn't ever have to fill in any details. Multiple payment methods, including optional soft credit. We also have bias protection and payment assured by Klarna for the merchants, so we eliminate risk at both ends, which is kind of valuable. We also promise that we improve the checkout rates for the merchants, so of course there is some technical interestingness to that. So what does it mean on a more explicit technical side? Well, minimal input required, one-click purchases, then we must be very careful about an automatic consumer identification and fraud prevention. For the multiple payment methods, yeah, we need to do real-time risk assessment. So for consumers we've never seen before, we still need to ask ourselves at Klarna, can we extend credits to this customer? And as I said, we eliminate risk, so that's another kind of real-time risk assessment. And last but not least, we want to optimize the user experience in order to have the best checkout on the planet. Just a few words about the credit line products. That's basically what we have, the pay now, pay later, slice it, variants of part payments and installments. So behind the scenes, now that we have a feeling of what is going on technically, there are three questions basically that are asked as soon as a consumer enters the Klarna checkout and wants to pay. The first question is, who are you? And that's the ID question, right? The next question is that really you? And that's the fraud question, right? And the third question, what's the chance you'll pay? And that's the risk question, right? And of course, we also want to optimize the user experience, so we have A/B testing going on at all times. Klarna footprint, well, yeah, we have presence in a number of markets. We have about 60 million users, which actually makes us one of the world's biggest banks. Which is kind of an achievement. So in terms of number of consumer footprint, we're comparable to HSBC and Bank of America and all that. 89,000 merchants, a bunch of employees. Yeah, about me. So I've been around at Klarna for 6 years now. I architected this data infra that we're soon going to have a look at. And before I went to Klarna, I did a PhD in database technology. So what's the mission of a data infra team? I thought about that a couple of days ago. I also thought about that a year ago. And I think a good answer is try to keep everyone on the lush and green data planet. We don't want to go to the chaos planet because then nobody knows what's going on. What does it mean to keep people on a lush and green data planet? Well, I think it boils down to 4 aspects. And this is really the table of contents of my talk now. We're going to talk about architecture, optimization, teams and practices, and tools. So let's start by talking about architecture. What is it that we run? So for the last 5-6 years, we've been running a Hadoop cluster. That's the centerpiece of the data infrastructure, if you like. Data sources include relational databases, cloud data sources, message queues, Kafka, what have you. Those are collected on Hadoop HDFS on the left-hand side of the distributed file system. Now, all the input data is there. All data that Klarna has ever seen is available here. That's fantastic. So now we can start running transformations. Those transformations on the data will produce output data, which will end up on the right-hand side of the distributed file system. That output data, in turn, is used for various purposes. More about that in a bit. Let's talk about the transformation here. Transformation takes input data, produces output data. Transformations can be chained like this, so we can have multiple dependencies. Transformations can also form, sorry about that. Transformations can also have multiple downstream dependencies, so you can build trees. And transformation can also have multiple upstream dependencies, so you can build graphs. So back to the Hadoop cluster again, we have input data, output data, and we have the transformation. Transformation results are exported for production purposes. They are exported to lookup databases, such as key value stores, including DynamoDB and Riak and Postgres and what have you. Those key value stores are used in production to help answering these questions. Who are you? Is that really you? What's the chance you'll pay? So in essence, what you're looking at here is we go from input data, whatever data we have at Klarna, we transform the input data into output data that is amenable for using to answer these ID, fraud, and risk questions in the Klarna checkout. And another purpose of the data is, of course, we want to have analysts, and this analyst in the corner, look what she's doing. She's actually looking at the yellow arrow, yellow transformation, and she's looking at the blue transformation as well. So she might be trying to develop this yellow arrow into a blue arrow and see which one is smartest. And perhaps you want to push the blue arrow into production sooner or later, if she figures out that the blue arrow actually produces more business value than the yellow one. Okay? A couple of fun facts. Everybody needs numbers. Here are some numbers. We've been in production for 5+ years. We have a bunch of data sources. And in fact, we are increasing the number of data sources now by about 10 data sources per week, which is kind of interesting. More about that in a bit. We have a bunch of storage. We have a bunch of users and so on. And another beautiful thing about this is the fact that we never had any unplanned downtime, and we never lost data. So HDFS is reasonably stable, comparable to S3, if you like. So what is it that we run? And what kind of transformations are we running? And I should back again, and we should mention something about those 9,000 Hive databases. Why do we have 9,000 Hive databases in the Hadoop cluster? Because Lambda. Right. Anyone heard about the Lambda architecture? Anyone running the Lambda architecture? Anyone thinking that Lambda architecture is outdated and should immediately be replaced? Yes, that's an expected answer. I like you. Yeah, OK, so Lambda architecture, making sure that we are all on the same page again. What's the basic approach in the Lambda architecture? Well, on the left-hand side of the distributed file system, we have data sources, right? And we never change that data. There are exceptions, of course. Customers calling in wants to be forgotten according to GDPR, then we do what we are obliged to, and so on. But basically, nothing is changing on the input data side. Then the Lambda function is a function of all data. So any analyst, any engineer wants to take input data and produce it into output data needs to express the analysis in the form of a function that is applied on all data. You might consider this wasteful in terms of CPU cycles, but I will tell you that CPU cycles are cheap compared to engineer time. And what we have seen, this immutability, data never changes, and re-computation function is a function of all data. The combination of these makes all analysis much easier to express, and the analysts and engineers will make less mistakes. That's the reason we run Lambda. But there is more value, actually. As soon as you say that, OK, I'm actually going to tag my transformation with a version number, so this function version 1.0 producing the gray database will now live in parallel with the function version 1.1 producing a blue database, then we can actually, since we know that these two functions have been applied on this exact same input data, then we can say that, OK, now we want to compare the gray output data 1.0 to the blue output data 1.1. So by maintaining Lambda and version transformations, we get two valuable things out of it, namely traceability and comparability. And now to shift gears once more, given that we have the comparability and given that we know that they were actually applied on the same data, input data, we enable continuous improvement. If we see that 1.1 is actually smarter, then we deprecate 1.0 and say, okay, 1.1 is the new happy place and everyone should be subscribing to 1.1 instead. As we said, applying a function on all data every day, every hour is rather expensive, so we have done a bunch of measures to optimize this Lambda architecture. Basically, the observation is that, okay, all the Lambda functions, all the Lambda-based transformations are following the basic same structure. They start with a linear projection, typically pulling out some stuff from CSVs or XMLs or relational tables and so on. The next thing is they do some aggregation. You can think of that as session inference in a checkout session or anything like that. And then we do the general data processing, which is basically the joins and what have you. And we have seen that the linear projection part of any data pipeline is very easy to express in an incremental form instead of applying a function over all the data. So we're on the left-hand side here, on the trivial part of the transformation, if you like, we go incremental, and by doing so, we save thousands of CPU hours every day. I'm going to skip a couple of slides because we have too many slides. And we had too much interesting stuff to talk about. Now, another optimization of the Lambda architecture is when we cross system boundaries. Recall that we took the data, whatever the output data was produced in the Hadoop system, and then we exported the whole data into a lookup query layer, if you like, such as React or DynamoDB. Now, pushing the entire data set, it might be several terabytes here, is causing pain both on the network and also on the destination database. So what we did in order to optimize this was to compare yesterday's result data with today's result data. And then we just synthesize a transaction log. We identified, okay, what has changed out of these 100 terabytes? There was actually only 2 terabytes that did change, so now we're pushing only 2 terabytes, a reduction by 98%. We're pushing only the changes from the last batch. And so we save a lot of network, we save a lot of CPU. Because again, CPU is cheap on this side, is more expensive when crossing system boundaries. Another interesting observation is that we partition the architecture in this way, that we have the data producers on the left-hand side, the data consumers and the result of transformations on the right-hand side, and the infra team in the middle. And then we can start reasoning about that. What is the infra team, first of all? Yeah, it's less than a dozen of people, actually. So we have 5 DevOps that is taking care of the Hadoop system and also the Kafka system. As I mentioned, we have 200 Kafka topics or something like that. And then we have a team of processing frameworks with a bunch of software engineers and a couple of data engineers. Now, this infra team is actually agnostic to whatever is going on in the domain. So the infra team typically does not really know or care about what those fields or what the data, the input data produced by the producers. They don't really involve themselves in the meaning of that data. Instead, that's something for the domain to agree on, which is formed by the producers and the consumers, whereas the infra just makes sure that the infra is running. So if you like, you could say that consumer data needs will drive producer data quality. And we have also seen that infra needs to facilitate this communication because it does not necessarily happen by itself. So typical questions that we want to facilitate is the question from the consumer to a producer. What does this field actually mean? So then over time, we will establish a reasonable semantic layer. But then we have more questions. Data consumers, those analysts and engineers running the transformation, they will eventually run into trouble. My transformation crashed, and I don't know why. And we have seen that these kinds of queries will swamp us from time to time. So what to do? Well, the solution is, in this case, was actually to build some kind of organization. We built a consumer community. In reality, this is just a Slack channel, but it's one of the biggest Slack channels on Klarna. I think we have about 300 members here. And 80% of the issues that the data consumer ever has is taken care of by this community. So by doing so, we eliminate a lot of work for the infra team, which is a nice thing. But see, there is more problems than that. A data consumer tells the data producer, we want your data. The producer will tell us, can you please ingest this data set, because the consumer wants the data set. And then the consumer says that we want to run this transformation on this new data. Can you please help us doing that? And we want to run it on a regular basis, because this should be pushed into production. And we want to use Uzi. Anyone used Uzi? Anyone loved making the Uzi configuration in XML? None. XML is fantastic, but it's not really made for humans. So what we did here was to provide some tooling. So for the producers, yeah, let's talk about the producers first. For the producers, we did standardized data ingestion. We said to all the data producers that, OK, whatever data you have, as long as it's on S3 or Kafka or in the former relational database, you just put the pull request in the appropriate data info repository. And as soon as we have approved that, the data will show up in a few minutes in the Hadoop cluster. That's the kind of tooling, that's the kind of process you need to have in order to scale this operation, right? For the data consumers, we built what we call high-level transformation packaging, which is basically gluing together the Java and the tooling and the Hive and the repos and the continuous delivery. That's a Jenkins here, right? And the continuous delivery pipelines and Uzi. So we're actually using HLTP. We provide a domain-specific language to all the data consumers, which is automatically translating all the specifications into Uzi code. So nobody ever has to touch Uzi. Instead, they are specifying the scheduling and dependencies on this very high level, and then it all gets compiled, so they never had to touch production. OK, yeah, so this is just a magnification. And to reiterate, Hive and tooling, the repo, everything that every analyst does is always versioned, deliver it, and then compile all the stuff to Uzi. So as soon as they have an HLTP job, they start to generate HLTP databases, Hive databases. And this is the reason we have 9,000 databases. So the first time around, when the transformation is executed, the result is a Hive database. One day later, the same transformation executes, now on new data, right? Resulting in a new Hive database. And the next day, we have another Hive database. And then we have another transformation up here, which with their job, which is also generating new Hive databases every once in a while in the same fashion. Now, in order for any downstream transformations to be able to get a grip on what database should I actually use here, we implemented another tool called Dataset Discovery. Which basically is binding Hive variables to the latest and greatest of each Hive database that has been produced by HLTP. So for the user, it's a matter of specifying what database they want to bind to. Is it major minor, is it major minor fix, if they are really picky. And then they will always get the latest and greatest. So to sum up here, HLTP, DSD, and Hive Runner will empower the data consumers to manage the data transformation lifecycle, including tests, release, deploy, scheduling, and troubleshooting. And by the way, Hive Runner, a unit test source framework for Hive, is something that we open sourced. So please go ahead and download Hive Runner and make sure it does a good job in your organization. It will save you years, I can promise you that. I think we are running out of time slightly, right?
No, it's very fine. Thanks a lot for the very nice talk.